Okay guys, today we're going to look at some functions and we'll do some examples of how we can evaluate them. We have kind of done this before, but it's worth just going back over some of the notation and so on. So often we see functions written as y equals, so things like a straight line graph or something like a quadratic, something like that. But often functions are written in function notation, which is written like this. It reads f of x equals, so I'll give the same first one, 3x plus 2, or you could say fx equals x squared plus 2x minus 6. So these are two completely different functions. Both of them are just functions in x, so it's basically just a link between an x and potentially a y. And we've done this before where we can plot these onto graphs. Okay, so this is some simple functions. Sometimes they might be written with different letters, whether it's f's or g's, h's are most common. And again, it could be a function in A or function in B, but that's okay. So we'll stick with some of these and we'll do some examples with them. Okay, so we'll go for an example here. If we have a function, let's call it fx equals, we'll stick that on a had, 3x plus 2. Then what we can do is we can evaluate different values of the function. So for example, we might say find the value when x is 1. Okay, so that says the f of 1. So I'll just continue that down and say, well, that's 3 times 1. Whenever I'm doing functions, I put it in a set of brackets to say I'm substituting that in for the x. So that's just 3 times 1 plus a 2. 3 times 1 is 3 plus a 2, hopefully is 5. So that says the f of 1 is 5. I could do this a different value. So I say the f4. That could be 3, same function, times 4 plus 2, 3 times 4 is 12, plus the 2 is 14. So the value of this function when x is 4 is 14. You could do exactly the same with negative numbers as well, that's absolutely fine, so put a negative 1 into that. So it's 3 times negative 1, then add on 2, so 3 times negative 1 is negative 3, add on a 2, brings up to negative 1. So there's some simple functions. We'll go for example 2. Let's take a function fx equals x squared plus 4x. Okay, we'll start off just by finding the value when x is 1. So f of 1 becomes 1 squared plus 4 times 1. Better off working here. 1 squared is 1. 4 times 1 is 4, so 1 plus 4 is 5. Let's try a different value. So let's do f of 3. Let's put that in. That's 3 squared plus 4 times 3. Again, rough working underneath. 3 squared is 9. 4 times 3 is 12. And 9 plus 12 should give us 21. Okay, and we'll just try a negative number as well. So let's do f of negative 2. Okay, shift a little bit. F of negative 2, so negative 2 squared plus 4 times negative 2. Negative 2 squared round is negative 2 times negative 2, so that's positive 4. And then add on 4 times negative 2 is negative 8. Add on a negative is the same as subtract, so that's 4 take away 8, and 4 take away 8 takes us down to negative 4. Okay, so you can do that with absolutely any function at all, whether it's got just 2 terms here, if it's 3 terms, a little bit of extra care. Biggest place where you'll make mistakes probably is when using negatives.